3.3. We're talking about systems of inequalities, so it's going to be very, very similar to what we've done before, except instead of having equal signs, we're going to have greater than, less than, greater than equal to, less than equal to, so on and so forth. Okay, so before we begin, here we go. I want you to do this. I have this system down here. X and y is greater than equal to 6, and then 5x plus 2y less than or equal to 20. So here's what we're going to do. X and y are only whole numbers. What do I mean by that? Yeah, no decimals, and they're not negative. You guys know that, right? Yes. Whole numbers are 0, 1, 2, 3, and so on. Okay? No negative numbers. So of the two inequalities I have here, I'll call this one number 1, and I'll call this one number 2. Which one of them, just by themselves, which one has more solutions than the other? The first one or the second one? The first one says, give me two numbers that two whole numbers when you add them together greater than 6. How many solutions would that be?
Countable infinity.
Yeah, huge. A lot of numbers, right? That has an infinite number of possibilities. However, the second one is a little bit different, right? It says that same number times 5 plus that same number times 2 have to be less than or equal to 20. So that one is bounded a little bit more. Do you understand that? So the first one, there's an infinite number of solutions. The second one is bounded. So let's start with the second one. We're actually going to solve this by using a table, all right? So I'm going to start by identifying the second one over here. So let's start with this, okay? 5x plus 2y is less than or equal to 20. X's and y represent whole numbers. So the smallest whole number that x could be is what?
1.
No, the whole number. Whole. 0. There we go. So if x is 0, I'll have 5 times 0 plus 2y is less than or equal to 20. So what does that mean? That means that 2y has to be less than or equal to 20, or y must be less than or equal to 10. Okay, that's a bound. Okay? One of my numbers can't be bigger than 10. Does that make sense? If the other one is the smallest one of 0. Okay. Let's go the other way now. Wait, what? I heard if the y, what's the smallest y could be? Yeah, 0 plus 2y is got to be less than or equal to 20. And if y is 0, then I get this. 5x is less than or equal to 20. So x has to be less than or equal to what?
4.
Okay, so there we go. So the biggest x could be is 4. And the biggest y could be is 10. Does that make sense so far? All right, good. So now what we're going to do is we're going to continue looking at that second inequality. Let's make a table of values for all that it could be. So I'm going to do x here. Okay, and I'm going to do y over here. Okay, x could be, the biggest it could be is 0, 1, 2, 3, or 4. You guys okay with that so far? That's the biggest x could be. Y can be what? 0 all the way through 10, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 if x was 0, okay? What if x is 1? Let's figure this out for each of these for 1, 2, 3, and 4. If x is 1, plugging a 1 into here, what would I get? I get 5 times 1 is 5, plus 2y is less than or equal to 20. So remember, right now we're only working with this one. Okay, only working with that one. If x is 1, what's y going to be? Or what could it be? Okay, so you're not... Yeah, you guys see what's going on here? If it's 1, if x is 1, here's what I get. 5 plus 2y less than or equal to 20. You guys good with that part? So 2y is going to be less than or equal to what? 15. So y is going to be less than or equal to what? 7.5. But what's the whole number? No, smaller than 7.5. 7. So this could be, what number? This could be 0, 1, 2, 3, 4, 5, 6, or 7. That's all it could be. Does that make sense? Okay. You get it? Oh, you get it now? Okay, similarly, let's go for the, if x is 2. If x is 2, it can be at most what? Good. 0, 1, 2, 3, 4, or 5. If x is 3, it could be 0, 1, or 2, right? And if x is 4, what could it be? Okay, so that's it. Those are all the whole number solutions for the second inequality. You guys agree with that? Yeah? Okay, now what we're going to do, let's highlight each pair of values that satisfies the first equation. The first equation. Remember, x can only be 0 to 4, y can only be 0 to 10. So here we go. if x is 0, right, then y has to be what numbers? 6, 7, 8, 9, or 10. How come? Because when you plug that into the first inequality, 0 plus 6, that satisfies it, that works. 0 and 7, that works. 0 plus 8, that works, and all those work. Does that make sense? Okay, what if x is 1? What does it have to be? It has to be 5, 6, or 7. How come? All right, when you plug 1, so if x is 1, 1 plus what number is bigger than 6, but also this constraint is still met? The number can only be 5, 6, or 7. What if x is 2? X could either, y could be 4, or it could be 5. What about 3? Nothing, right? Why nothing? Very good. Very, very good. There's no 3 and 3 can be the least. So, and then how about 4? Could it be anything for 4? So the only pairs of numbers that will work are the highlighted ones here. So this is an example of one that would work. 0, 6. That would work. You guys agree with that? What else would work? 0, 7. What else? 0, 8. Right? What else?
Which equation are you using right now?
0, 9, 0, 10. I generated the table using the second inequality, and I'm generating the highlights using the first inequality. Okay. Give me another pair that would work. 1 what? 1 5. Give me another pair that would work. 1 what? Give me another pair that would work. 1 what? 1 7. Good. Give me another pair that would work. 2 4. And then what? 2 5. Good. And that's it. Those are the only pairs that would work. The more conventional way of solving a system of inequalities, though, is to actually use the graphing technique and see where these lines overlap, okay? So what we're going to do is we're going to solve it by hand, and then we're going to actually show you how to do it in the calculator as well. All right? So for the first one, we've got 2x minus y is greater than or equal to a negative 3. It might be helpful if we actually took this inequality and rewrote it in a form that's easy to graph. So I would get negative y is greater than or equal to negative 2x minus 3. But then if I want y by itself, I would divide by negative 1. So y would have to be less than or equal to 2x plus 3. Okay? So if I'm going to graph that less than or equal to 2x plus 3, I'm going to go up to 3, right? And then from there, I would go up 2 and over 1, right? So it would look like this. Whoa. Hopefully you guys use the straight edge, right? And look a little better. Okay, so that's alright, that's pretty bad. So we want values that are less than that, right? So we want these values down here. We want all of these values. So we want everything that's less than that. Is this making sense so far? Okay, now I'm going to use a different color now to actually show you. Greater than negative 1/2 x plus 1. If I go up to 1, the slope is down 1 over 2. Right? And it's a solid boundary line because it says less than or equal to. The dark region of the answer. So we want things that are greater than this, right? So we want things above this line. So where do my answers lie? My answers are bound by a region, right? So this is my region right here. So any x in that region would satisfy both linear inequalities. Does that make sense? Okay, I'm going to actually show you how to graph this on the calculator so that you can check and see. So take your graphing calculators out, and we're going to plug these in. I'm going to show you where the inequality signs are, okay? It's actually pretty neat in the calculator, and the colors make it look really pretty. Okay. So let's clear all this out if you have anything in there. Clear anything out that you might already have. And we're going to plug in 2x plus 3. 2x plus a 3. And then we're going to plug in a negative 1/2 x plus 1. So I'm going to go negative, parentheses, or actually I don't need that. I can just go 0.5x and then a plus 1. So I have both of them in there, right? Okay, here is where you need to look. Do you see on the left-hand side of the y1? Most of them should be this line here, this diagonal line. But you can change that. You can actually change that to different functions. So take a look. If you move your cursor all the way over to the left, there'll be a box around that little blue and then the little line here. Now, I want everything that is less than 2x plus 3. So if you push enter, you see this screen come up. You have the ability to change the line color, but you also have the ability to do the actual line itself. So most of you right now are on, sorry, whoops, sorry, go back. Yeah, so there you go. Most of you right now are on this one, right?
Yeah.
Yeah. So if you push your cursor, if you push the right key, notice you get an upper triangle. That stands for greater than. And if you push again, you get a lower triangle, and that stands for less than. Pretty sweet, right? And then I think you just go down to OK and push enter. You can also hit enter twice. Okay, do the same thing for our second inequality, except we want greater than, don't we? So we want things that are greater than this. So you can actually go down and then push enter, and then get into this little window here by pushing down, and you want to be on the triangle in the upper region like that. That stands for greater than. Once you've got all that in your calculator, everybody hit zoom 6, so we're staring at the same thing. Okay.
It says invalid. Mine says invalid.
So dumb.
Okay. So.
That's cool.
So there's mine, and then okay. All right. So
And then that one part's the. How would
check
you,
that
How
out.
would you ever?
So this is the region right here, and you can see that it's the exact same region that we came up with, except this one looks way prettier than my little drawing, right? Okay.
It's good. Don't put yourself down.
Okay. Thanks. Thanks. Okay, I'd like you to actually graph this in the calculator and sketch the shaded region. Try this one all on your own. So when it's all said and done, you should have a sketch that looks like this on your page. And you need to give me a good scale, use straight lines, tell me where the region is, and you can use your calculator to make sure you did it right. But you'd have something that looks like that. Here we go. You do not need to copy the actual word problem. Let's just read it and talk about it, okay? It says, your city's color rating center is sponsoring a concert to raise at least $30,000 for the city's youth services. Okay, tickets are $20 for balcony seats and $30 for orchestra seats. All right, cool. If the center has 500 orchestra seats, how much of each type of seat must they sell? Okay, so the first thing that we want to do is what? Whenever we have a word problem? Yeah, good. We're going to define our variables. So what do you guys want to do? Let's define some variables. I like it. Let B and L, okay. Well, let B equal balcony. Okay. B is balcony. What else do we have?
Y equal orchestra.
You want Y to be orchestra?
No,
Oh, equal orchestra. Okay.
No, you should do R for C. Yeah, no, do R for orchestra. The O is going to be like 0. C for orchestra.
Just do X and Y.
Just put it as R. Yeah.
Okay, R is orchestra. Okay, good. So now, let's start to relate these two variables. So the first thing I'm asking you to do, good, we defined our variables. B is a balcony, R is orchestra. Okay, R is orchestra. Now, how are these related to each other? Tell me something. Jake, what do you see?
Well, I see price and I see like how much. So you
Yes,
say
price and how much. Good, I like that. So, how much does each balcony ticket cost?
B plus R equals 500.
500, yeah.
B plus R equals 500?
Yeah.
No, I don't think so.
R equals 500.
Why? Oh, orchestra seats.
Orchestra seats. Has it equal that? At most. So R is going to be less than or equal to 500 because you can't sell any more seats than you have tickets, right? Or sorry, tickets than you have seats. So it has to be less than 500, right? You could sit on the ground, but that's a fire hazard. No? Okay. All right, so what else do we know?
20B plus 30R.
Yeah.
But
$20 for a balcony seat plus $30 for an orchestra seat. Oh, that's R. That's a good thing we use R, right? For an orchestra seat has to be at least how much money? So greater than or equal to $30,000, right? Okay, here's your task. So you have defined some variables, good. You have given me a system of linear inequalities, okay? I would like you to plug that into your calculator and come up with a region adjusting your window correctly.
so R would
Some people were a little upset that we used B and R, that we can use X and Y. Okay?
actually was only me.
So to get this done, first of all, do you have this all set up? You should have y is less than 500. Okay, and we changed our variables to x and y to represent everything to keep it the same. So if you're going to put it in your calculator, you might want to do that too. All right. So then the other one we had was negative 2/3, and use parentheses to keep the 2/3 in where it is. You don't have to in this particular case, but when you get onto more advanced expressions, you're going to use the parentheses. So just keep those in there. So negative 2/3 x and then 1,000, that should be in there. And you want things that are greater than that. So that should be here. So now, if I just hit zoom 6, oh no,
Get blue.
you just get blue.
No, you get
Okay,
ocean.
that's right.
She goes surfing.
How do I?
Alright, we're serious.
Thank you. How do I? So I don't want you guys coming up to me in the test and go, Mr. Dorio, my screen's blue. What's wrong? Okay, you have to be able to think past this and understand what's going on. So.
You ate that Willy Wonka gum, that's why.
What?
Let him teach, guys.
Okay, walk me through your window that you used. Okay, what's your x minimum? What does x represent in this case? Think about it. Balconies, right? Okay, so it can't have negative 10 balconies, so 0 is a good place to start. Okay. What did you guys use for your x maximum? 5,000?
2,000.
5,000. Okay. What scale did you use? If you're going from 0 to 5,000, what's a appropriate scale we could use?
500.
500s. Okay. All right. Okay. What does y represent? Y represents orchestras. Okay. So the lowest it could be is 0. The highest it can be is what? 500, right? Isn't that what it says? So let's go to 6, just to, let's go to 6. All right, and what scale should we use? What's an appropriate scale? 20, okay. So now, when I hit graph, does this help my situation out at all? Let's see here. That's pretty good. Hey.
Mine says error.
What doesn't do that though?
Can I see your window again?
Let me out, Hank.
Okay, so does mine look like yours?
No.
No? Did I do something wrong?
I don't know.
Okay.
It looks
So there we go. Less than 500, and then greater than. Yeah, negative 2/3 equals 1,000. Yep.
Oh.
Okay. So back to my graph. I can see that. So, which ones of these? Where does my region make sense here now? So finally, this last one. There you go. Y is less than or equal to 3, and then greater than. So the region is this little tiny triangular region right here. Do you see it? That's what we're talking about for that little part there. And to plug that in, I use that. And the absolute value button, for everybody who doesn't know, is underneath the math. Go over to number, and it's absolute value. It's right there. Plug it in, okay? All right, there you go.